Today we're going to look at curve sketching and how it can help us to understand what a graph is doing. And we're going to do this based off of derivatives. And just with the little information the derivative gives us, we'll now know a lot more about a graph. So there's three definitions right here off the bat we need to know. First, a critical point is defined as the first derivative set equal to 0. You also want to look where the first derivative is undefined. Okay, both of those cases. Now, a local max happens when you have a critical point that comes from positive to negative in the derivative graph. And you will see me very often, I'll make a little T-type chart that here's my critical point, point A. If I can have the values that it's going from positive to negative, there's the local max I'll be talking about. And a critical point going from negative to positive in the derivative graph, that's going to be our local min. So again, you'll have here this section's negative, this section's positive. Now it goes down, then up. Now that's a local min. So looking at this, first we're going to look at actual original position graphs. Okay, so starting at this, it's very easy to see I have a local min right here. I have a local max right here. And we say local just meaning in this section of the graph, because I can also see there's a local min right here. Now, going further into conversation, we would talk about how this local min here at -1 is a more negative, so it would be the absolute. We'll get there. Okay, so let's take a look at what that graph would look like. So you can see it's written on top of each other. There would be the derivative of that. Okay, you can see here at 0 and here at 2 and 4. All of those critical points helped us create that. Put that back away. Over here, looking at this graph, I can see that I have the 1 local min right here at 1. Now something definitely happens there at -2, and we'll investigate it. You can't say that it is a local min or max because it's not. You can see this section is above, and then this section always decreasing there, where this section decreasing and then increasing. I did that without arrows. So you can see this is always decreasing. We're decreasing to increasing, and what creates the local min there. Now the next level is something you're going to see a lot. So if we can process it today, it's going to be awesome. These are derivative graphs. And from the derivative graph, I'm going to identify what happened. First, find the critical points. Critical point at -2, critical point at 1, critical point at 3. All of those are considered critical points because they went, the first derivative graph was set equal to 0. So now here at -2, it went negative to positive. The graph below was negative. So a minus to a plus. So if I go down, then up, this is now a local min. The next one right here at 1 goes positive to negative. Draw the little T-chart. I'm going to go positive to negative. Now I've got a local max. And then you can see how 3 works, negative to positive. I have another local min. So I'm going to come up here, put it in the center for just a second. And you can see here we have -2, local min, 1, local max, +3, local min. So using the same ideas, go ahead and try B now. Take a look at it, identify. These are critical points. These are local mins. These are local max. Now I'm sure you've paused the video. Let me show you what happened here. You can identify that you had critical points at -3, -1, and 1. Because at 1 it went from positive to negative, you have a max. Because at -3 it went from negative to positive, you have a min. at -1, it went positive to positive. So that was neither a max nor min, but you can see how the slope is 0 right there. So here are the different steps you will need to do a curve sketch. Now, a curve sketch is really taking steps to understand higher level things. Yes, I know you have a graphing calculator. Yes, I know you could do it. Using the derivatives to help us do this helps us understand why it works. So take a screen capture here. I'm going to go through them first. You take the derivative. Then critical points are found. Remember, that's the first derivative equal to 0. Then you check if they're local mins. You check points around them. Then, if you want to be very specific, you find the y values of those functions. You do that by the original, and then you sketch it on an axis. So here we go. I'm going to show you what I mean by that. Second derivative test helps us out with concavity. So here you go. You can take another screen capture. We're going to look at this. If I have the first derivative is positive, the slope is positive. The first derivative is negative, the slope is negative. When I'm walking on second derivative, if the second derivative is positive, then it's concave up. And the second derivative is negative, it's concave down. We've gone through these here. You're going to find your different tests. You're going to figure out max and mins, concavity, and go from there. So here we have our very first function that we're going to do. And if it makes you feel better, go ahead and graph it right away. And you'll see what it looks like. I'm going to go through. I'm going to take the derivative. So f prime of x, remember that symbol means derivative. Power rule, 3 comes in front. Squared, losing a power. Bring the 2 in front, I'm going to have 18. X, and then minus 48, and then the derivative of 52 is 0, so that goes right away. I'm going to GCF out the 3, and I'll have x squared minus 6x minus 16, and I'm aware that 0 goes away because I can divide the 3 out there. I'm going to factor. I'm going to have x and x, 8 and 2, negative in here, positive here. So I have critical points of positive 8 and negative 2. You can make a little statement right there. That's all they are right now, is critical points. Make a little T-chart. Okay, so you're going to check sections around each of those. Yes, you have the calculator. You can go ahead and graph the derivative and see what it looks like. I'm going to plug in easy values for myself. So here, a number between negative 2 and 8 would be 0. So 0 squared minus 6 times 0 minus 16. That's going to end up with a negative number. If I go over here and I pick 100, that's definitely bigger than 8. So 100 squared, well, that's definitely big. 6 times 100, I'm going to subtract off some, but I'm still going to end up with a positive value. Notice I'm not putting any energy into what the y value was. It does not matter as long as you figure out that it's positive or negative. Try picking a value now less than negative 2, negative 3, negative 100. Anything in between works. When you test that point, you will get positive there. So now this part goes positive, then negative. Now you know that negative 2 is a local max. And then at 8, it went negative, then positive. So down, then up. This is a local min. So then you would go ahead. You could do by hand or check in the calculator. You're going to find out the values of negative 2 and 8 by plugging them into the original. And you're going to get the points negative 2, 104. And 8, negative 396. So my graph, let's see if I can pick it up here. There we go, success. So at negative 2, I have 104 up here. At 8, I have negative 396. And so you, of course, plot those. Positive. Here we go. There's the local max at negative 2, local min at positive 8. Okay, here's one for you to try. Go ahead, and you've already figured it out. You can make sure your graph is right by graphing in the calculator. Remember, we are not learning how to graph right now. We're learning how the graphs help us. Okay, great. Let's go on to number 3. Number 3 now, let's take a look. I will take the derivative first, and I will get 4x cubed minus 12x squared. That's your first step, to take that derivative. Now, you're going to go through, set that equal to 0. Setting it equal to 0 will give me my critical points. I'm going to take an x squared out. I'm going to be left with 4x minus, oh, take a 4x out. 4x squared out, and I will be left with, take this 4 right here. I will be left with x minus 3. So then I can see that I will get x equals 0 and x equals 3. Okay, now I'm going to look around there. I'm going to plug in values into this. If I plug in 1 right here, 4 times 1 squared times 1 minus 3, I can see that this is going to be positive. This part's negative, so the overall value is negative. If I go over here and I try negative 10, I'm going to have 4 times negative 10 squared. That's going to become positive. And then negative 10 minus 3, that's negative. So I have negative, negative. I'm going to check over here. Let's go positive 10. And you can see that that's definitely going to be a positive value. So here is something we need to notice. This did not change sign, so it is not a local max or min. Here, it went from negative to positive, so that is a local min. Okay, but there was no change in concavity in the other spot. So now you would plug back into the original. F of 0, 15. F of 3 is negative 12. And what you can see is that there's only that local min there. So something definitely happened, and we're going to learn more about that at 0. But we'll have 0, 15 will be here, and then 3, negative 12 down here. So this did something. It's still going down, and then it came down to the local min. I'm going to show you one more example using the first and second derivative. Now the second derivative is new for us. That's what's going to test the concavity. So the first thing you're going to do, take the derivative, it's 3x squared minus 6x. Take the second derivative. Of course, can do it later, but I'm right here, so why not? So I have 6x minus 6. Setting the first derivative equal to 0 gets me my critical points. So I have x equals 0, x equals 2. Setting the second derivative equal to 0 gets me my inflection points. So this is a possible inflection point, and these are critical points. Testing this here, I'll let you do it, but you'll end up with plus, minus, plus. Again, you're testing those points in the derivative around there. So I have negative then positive, local max. And here I have negative to positive, local min. Testing the second derivative, this section is negative. I plugged in right here 0. I end up with negative 6. Plugging in 2 gives me a positive number. This section is concave down, and this section is concave up. So now you would find all of the y values, and then let's do that. So I would have the point 0, plugging into the original, 0. Plugging into the original, negative 2, or positive 2, negative 4, and 1, negative 2. You're going to plot those and show the concavity, and you will be able to check that on your graph. Have a great night.